Today we're going to begin section 8.3, solving right triangles. Last week we focused on using trigonometric ratios to find the side measures in a right triangle, and today we're going to start looking at using those trigonometric ratios to find angle measures in a right triangle. So before we get to that, let's do a little review of what we did in section 8.2. Our example says to find BC and AB to the nearest hundredth. So let's start with finding BC. Let's call BC X, and then I'm going to circle my acute angle that we are given, which is angle B, 59 degrees. So you can see that we are also given side AC to be 12, and that would represent our opposite side in this example, because it is across from my given angle. So that would mean that if we take a look at X or side BC, that's across from our right angle, so that would have to be our hypotenuse. Okay, so recall what we were discussing last week with our trig ratios. One of the sayings that we used quite a bit was Sohcahtoa. So if you look at our picture and what I just labeled, we're working with our opposite side and our hypotenuse. So if you look for O and H in Sohcahtoa, that would go with so, which represents the sine function. So that would be the way to set up this equation. I can say sine of angle B equals my opposite side over my hypotenuse. So now I can substitute in what we know. Sine, we know angle B is 59 degrees. We know our opposite side is 12, and our hypotenuse is X. So now to solve for X, we would want to multiply by X on both sides. That removes X from the denominator because those cancel out. So now we have X times the sine of 59 equals 12. So if we want to get X by itself, we would now need to divide both sides by the sine of 59. So go ahead and get a calculator out if you do not have one already. And remember, our directions said we can round to the nearest hundredth. So X equals 14.00. So in your calculator, you should see 13.999 and so on. So we would round that up to 14.00. So that would represent BC or X. Okay, next up, we need to find AB. I'm going to go ahead and erase this, but it will include both on our completed notes. Okay, so if we're going to find AB, I'm going to let AB be Y, since we already used X to represent our BC. So in this case, we're still given that same acute angle, so 12 would still be our opposite side, but now we're not working with our hypotenuse anymore. We're working with our opposite, and Y would represent our adjacent side. So if we're working with the opposite and adjacent side, it would make sense to use the tangent function, or the tangent trig ratio. So we can set up our equation by saying tan of angle B equals our opposite over our adjacent. So tangent of 59 equals 12 over Y. So we're trying to get Y by itself. This is kind of the same process as the last one, so multiply both sides by that variable. So we have y times tan of 59 equals 12. Then we can divide both sides by tangent of 59. Go ahead and put that in your calculator and round the nearest hundredth. And you should get 7 and 21 hundredths.